The next thing we're going to focus on is solving rational equations. The basic strategy we're going to use to solve rational equations is to make sure we multiply through by the least common denominator. In our first example, 6a, the only denominator that we have in our problem is the x plus 3. Just remember that a fraction bar is a grouping symbol, so that x minus 3 is an entire value or an entire denominator. So we have our equation, our original equation, 20 over x plus 3 minus 4 equals 0. Now the strategy that I just mentioned is we're going to multiply both sides of the equation by the least common denominator. In this case, the only denominator is x plus 3, so we're going to multiply through and distribute an x plus 3 on the left side, and then we're going to take 0 times x plus 3, which is pretty convenient because it still stays 0. So when we distribute the x plus 3 to this term, the first term, the x plus 3 factors will cancel. So this factor will cancel out with this one. So we have just 20. When we distribute, and that's the important part, make sure you distribute to both terms on the left side, we have to take a negative 4 times x plus 3, and that's going to equal 0. The next thing that we do is we distribute our negative 4. That's a pretty simple process for us. What we got to remember is make sure you distribute a negative 4. So it's a negative 4x minus 12 equals 0. And then we're going to collect our like terms, our 20 minus 12. So we have a negative 4x. And then we're going to have plus 8 equals 0. My preference would be to make the x's positive, so I'm going to leave the 8 on the left, move the 4x to the right, so I'm going to add the 4x. So that means x is equal to 2. So we found a solution. What we want to do is make sure we plug it back in and make sure that it works, and make sure that it does give us the correct solution. So if we put in a 2 in for x, 2 plus 3 is 5, so it's 20 divided by 5 minus 4 is equal to 0. Well, 20 divided by 5 is a 4, so we have a 4 minus 4 equals 0, and our solution checks. Okay, so again, being a good practice of checking your solutions, there are times when we're going to, again, introduce extraneous solutions or extra ones that can't be used. Also, keep in mind, whenever we're working with rational equations, there's a limitation on our domain, so we had to make sure that we never use an x value so that x could not equal a negative 3. So if we ever got that in our solution, we'd have to disregard that anyway because it would not be defined in our domain. Second example, we have 9x all over x minus 2 equals 6. Now this one you might want to consider just a little bit differently. I'll just show you a different strategy. We can multiply both sides times its denominator, and the only denominator in this whole equation is our x minus 2. So we're going to multiply both sides by x minus 2. So you can think of it over 1. You're going to multiply this times x minus 2, and you're also going to multiply this 6 times x minus 2 over 1, just if you want to make the fractions appear numerator and denominator. So this x minus 2 factor will cancel out with that x minus 2 factor, and we're left with 9x equals, now we have 6 times the quantity. I didn't put it in parentheses, and I should have because that's the whole factor we need to multiply by. So it's x minus 2. So we have 9x equals 6x minus 12. Which means we have 3x equals a negative 12, which means x would have to equal a negative 4. We're going to come back, we're going to check that in there, make sure it satisfies our equation. So we're going to take 9 times the negative 4, which is negative 36. We're going to take negative 4 minus 2. Negative 4 minus 2 is a negative 6. We want to make sure that's equal to 6, and that's exactly what it is. A negative 36 divided by negative 6 is a 6. So, as you can see, these aren't that complicated. Some of these are quite easy to simplify. You just have to get the basic strategy. We can eliminate the denominators by multiplying through by the least common denominator.